Hi, let's continue with our section, and this video we will talk about the introduction to Pytorch. So the first thing is, what is Pytorch? So let's write some text for that. So Pytorch is a Python based machine learning library, and it has two major. So there are two major features in Pytorch. So what is the first feature? So the first feature is it has the ability to efficiently perform tensor operation with hardware acceleration, which is usually GPU, and the second feature is it has the ability to build deep neural network. So that is the two main features. And also Pytorch is a very popular library. So Pytorch is a very popular library. So now how can we install Pytorch? So if we use Jupyter Note, we use the Google Colab, so the Pytorch is installed in our Colab. However, if you want to use Jupyter Notebook, you have to have the conda install Torch, and then we got Torch vision.c, and then Pytorch. So Google Colab already have one, so we need to check. So checking that Pytorch is working properly. So we need to define the Pytorch. So we need to have the import torch, and then x equal torch.tensor. And then we need to have is 3 point, 4 point. So let's run the cell. So we need to bring x. And then let's bring, so we got tensor 3 point and 4 point. So that means our Pytorch is installed and working properly. And now we can perform some multiplication. So perform some basic operations such as multiplication. So in here we have is we just need to define this one, and then we got y. So I just change to y, and then we got torch dot tensor. This will be 5 and then 6. So if we bring x times y, so let's run the cell. So we got 15 and 24 point because we got 3 times 3 multiplied by 5 is 15 and 4 times 6 is 24. So that is really good. And now let's understand tensor. So what is tensor? So tensor have a property known as order, which will determine the dimensionality of a tensor. So an order 1 tensor is a tensor with a single dimension, which is equivalent to a vector or a list of number. So the same with tensor order 3, order 2. So an order 2 tensor with 2 dimension is the same as the matrix. And tensor of three tensor of order 3 is will have 3 dimension. So it's very simple. And now let's build a simple neural network. So neural network with Pytorch. So in here, I already mount the drive. So I did include the code. So it's very simple that you just mount the drive and then connect to Google Drive. And then you just connect, allow. So it will run to mount the drive. Just wait for a bit, and then in here I did put a dataset into the Pytorch dataset, so it contains the train dataset and a test dataset. So I did attach this dataset in the resources in this lecture, so please download it. So first, we always need to load the dataset. Load dataset. So we need to import pandas as PD. And then in here we got train equal pd.read underscore csv read underscore csv. This will be the train.csv. And then we put a train label, so train labels equal train, and then we open bracket label dot values. So we have no mistake. So now we need to reshape our input to 112828. So this is a tensor of 1,000 times 1,000 images. So each image has 28 times 28 pixel. So we need to use train equal train dot drop. So we have is label comma axis is equal to 1 dot values dot reshape, and then we need to put length train comma 1 comma 28 and then 28. So we have no mistake. So now training data and label will be converted into tensor. It will have to fit them into neural network. So in here we got is x equal torch dot torch dot tensor. So we have a train dot as type, which will be float. And then small y equal torch dot tensor. This will be train underscore label dot long. So let's run the cell. So there are two tensors. So the first one is the float tensor, which has 32-bit floating point number. The second one is the long tensor, which has 64-bit integer. So the x variable has to be float, as it will have Pytorch to compute gradients. The y variable, which is our label, has to be integer, because we will predict values of 1, 2, 3, and many more. So our neural network, so we need to have class MNISTC. So it should be classifier. This will be NN dot, should be the classifier NN dot module. So in here we need to define the init function, which will be self. So we have the super dot underscore init underscore, and then we got self dot fc1 equal nn dot linear. So it will be 784, 392. So I just copy the order 1, 2, 3. So should be 392, and then 196, and then we got 196, and then we got is 98. And then we have is 4, which will be an end dot linear. This one is 98, and then 10. and then we have is self dot drop out equal nn dot drop out. So we got b equal to 0.2. So let's explain it for a bit before we move on. So this is our first layer. So our first layer has 784 input, as the size of each image is 28 times 28. And then we got is this one is a second layer. So second layer has 392 units as input. And then we got is this one is a third layer, and it has 192 and so on. So in here we'll have is the output is the final layer, and it has 10 units. So the reason for that is we try to predict whether the image is a digit between 0 and 9. So why we need to have the drop out? So drop out is a way of regularizing our neural network to prevent overfitting. And now we need to have the other. So now we need to define the forward pass. So we define the forward, which is a self comma x, and what we have in here is x equal x dot view. So we have a x dot shape is 0 comma -1. So x equal x dot drop out. So in here we got is f dot relu. So we have is self dot fc1, and then we got x. 1, 2, 3. So self dot f2, and then f3, and then we got x equal f dot log underscore soft max. So we have self dot fc for x, and then we got dim is equal to 1. So the forward function will define the path our input will take throughout the network. So what does it do? So it will take our input x and reshape it for use within the neural network. Transform it into a one-dimensional vector and then pass it through our fully connected layer, and then wrap it with ReLU activation function to make it non-linear. And after that, we will grab it in our dropout, which was defined in the init function. And for the prediction layer, we will use the softmax layer because it will have us to calculate the loss function much more easier. And that is all in this video, so we will continue doing in the next video, and I hope you enjoy it, and I will see you in the next video. Hi, let's continue with our section, and this video will continue what we have done so far. So we did build a classifier. However, we did not define the NN and F over there, so we need to define it. So let's write some code before that. So we need to use some of the libraries. So first we need to use the matplotlib .pyplot as PLT. We need to import from Torch, import NN, comma of team, and then we need to import NN dot Torch dot NN dot functional. So as f, and then we need to import torch dot utils dot data as data. We need to import torch, and then finally we need to use from torch dot auto grad. We need to import variable. So let's run the cell, and so I think I will just copy this one, go at the top, and in here we will show some image. So im show plt dot im show, and we dot np dot reshape. So we have is df dot values 0 and then 1 comma 28 comma 28, np dot reshape open bracket df dot values and trend, and then we have is comma c map equal plt dot get underscore c map, and then we get is great, and then we have plt dot show, which will plot the image. So we need to import numpy as np as well. So let's rerun the cell and then rerun it. So plt dot im show np dot reset. So I did make a pause and fix all the errors, and because I did run until the end as this time, so I need to rerun on the cell again. So that is, we got the image over there, and then we need to reset, and then we train data and labels, and then convert, and then we build a neural network. And also I did fix the error in the classifier function. So in here we need to have, so before that is on FC1111. In here I fix it to FC1, FC2, FC3, and FC4. And also in here it have to be self dot drop out because it's only in that function. So I did also fix that. So we have self, and then self dot FC4, and then we return X. So now it will be good for our neural network. So now let's continue writing our code. So in here we will setting the model parameters. So in here we have is model equal classifier, and then in here we got loss underscore function equal to nn dot nn n l loss, and then we got op is equal to optim dot adam equal optim dot adam. This will be model dot parameters, and then we got lr is equal to 0.01. So let's run the cell, and now we need to train our network. So train our network. So in here, first we need to create a loop that runs once for each epoch of our training. So here we will run our training loop for 50 epochs. So we will first take our input tensor of images and our, so I need to write a new one. So our input and our output tensor of labels and transform them into Pytorch variable. So a variable is a Pytorch object that contain a backward method which we can use to perform. So let's write some code for that. So first we need to for epoch in range 50, and in here we have images equal variable x, and then we'll have is labels equal variable y, and then next we will call the 0 underscore grad on our optimizer to set our calculated gradients to 0. So within Pytorch, gradients are calculated cumulatively on each back propagation. So while this is useful in some models such as when training RNN with a recurrent neural network, we wish to calculate the gradient from scratch after each epoch to ensure to reset the gradient to 0 after each pass. So we have a of dot 0 underscore rat. So now we will make usage of our model current state to make predictions on our dataset. So this is effectively our forward, but as we then use this prediction to calculate our loss, so we need to have the outputs equal model, and then we got images. And then using the output and the true label of our dataset, we calculate the total loss of our model using the define loss function, which is in this case is the negative log likelihood. So we need to have loss equal loss underscore function, and then in here we'll have the output and the labels. So we have the loss dot backward. So this one is called the back propagate our loss through the network. And then we have a of those steps. So in here we use step. We use step using our optimizer in order to update our model parameter. And then after each epoch is completed, we bring the total loss. So now we just bring, which will be the epoch percentage d divided by percentage D, and then loss is percentage 0.4F, and then we have is percentage open bracket epoch plus 1 comma 50 comma loss dot data dot item, and then run. So I did make a pause and fix the error. So I think I misspelled model in here. So let's rerun again. So as you can see, we got the loss is reducing. So from A to 0.04, and that is really good. And that is all in this video. So I hope you enjoy it, and we will make a prediction in the next video, and I will see you in the next video. Hi, let's continue with our section, and in this video we will make a prediction. So make prediction. So now let's write some code for that. So first we need to create a test variable where we will have a test to our model. So we got pd.read underscore csv open bracket test dot csv. So I think it's in a folder of Pytorch dataset. So we'll have the test underscore labels equal test, and then we'll have its label dot values, and then we have its test equal test dot drop, and then we'll have its label comma axis is equal to 1 dot value dot reshape, and then we got len test comma 1 comma 28 comma 28, and then we got x underscore test is equal to torch dot tensor, and then we have is test dot as type, and then we got float, and in here we have is y underscore test equal torch dot tensor, and then we have create a test underscore labels, and then we have is dot long. So let's run the cell to see is there any error, and there is no errors. So let's explain it. So here we perform the same step as the training step, and then we our data, our test data is reshaped and transformed into Pytorch tensor. So now we need to make the prediction. So we will press equal model, and then we have x underscore test, And then now we will bring press, and then we got 0. So this is the result that we got. So let's analyzing it. So as you can see from the above result, our prediction is a vector of length 10 and with a prediction for each possible classes. So the one with the highest predicted value is one our model chooses as his predictions. So as we use the softmax, log softmax, our predictions will not be raw probability. So to convert it, we need to transform using the X. So now let's construct a summary of the data frame. So construct a summary data frame. So what are we doing in here? Underscore prediction label equal to torch dot max open bracket bread press dot data comma 1, and then we have the prediction label equal to prediction label dot to list, and then we got is in here that this will be equal to pd dot series test underscore label, and then I think the test underscore label will be the S. And now we got a test underscore label equal to bd dot series. This will be the test label. So we got prediction label dot to list, and then we got pd dot series, which is the prediction label, and then we got a test labels pd series test label, and then we got is predict bread underscore table equal to bd dot concat open bracket prediction label comma test underscore labels, and then we got a axis is equal to 1, and now we got a breadth underscore table dot columns equal to predicted value, and then comma true value. So we'll display the breadth underscore table dot head. So the head function will bring only the first 5 results. So we got predicted value is 9. For the first one 0, we got predicted value is 9, true value is 9, and then we got predicted value is 8, true value is 5, 2, 6, 2, 4, 4, and 1, 1. So I just make a pause and fix on the indentation, so I make the code more clear. And this is the result that we got. So we got 9, 9, 6, 5, 2, 2, 4, 4, and 1, 1. So it's a very good result. And we got this one is very close as well. So 6 and 5. So now is the time to evaluate our model. So evaluating our model. So in here we have is press equal to length, and then we will have is prediction label, and then we have is correct equal length. So we have is 1 for x, y in zip open bracket. So we have is prediction label comma test underscore label, and then if x equal y, and then now we will bring the percentage. So we have bring correct divide by breadth, and then we got is time 100. So let's run to see what is our result look like. And this is 87%. So that is really good result. So our symbol neural network has been able to identify 87% of the unseen digit image. And that is really good result, as our one is just a simple neural network. And that is all in this video. So I hope you enjoy it. And that is the end of this section as well. So I hope you enjoy it, and I will see you in the next video and next section.